Hello everyone, I am Dr. Bhupali Sharma, Assistant Professor, Department of Physics, Ayurveda College, Guwahati. Today's class is meant for higher secondary, second year students, that is class 12 students. And in this class, we will discuss few topics of electrostatics. So let us start with what is electrostatics. So in very simple words, you can say that study of stationary charge is known as electrostatics. That means in electrostatics we study the behavior of one single charge when it is alone or when it is in the environment of other charges as well. To understand electrostatics, let us first know what is electric charge. So it is a basic property of matter carried by some fundamental particles like electrons and protons, and by virtue of this fundamental property, one charged body can attract or repel another charged body. So for that, so let us take one example of rubbing of one glass rod with the help of one silk cloth. So before rubbing, they won't attract or repel each other. But when you rub the glass rod with the silk cloth, then after rubbing, they will tend to attract each other. And that is because of the transfer of charges that takes place between them when you rub them. Okay. So what actually happens that some of the electrons from the glass rod is removed and it goes to the silk cloth, so that the glass rod becomes positively charged and the silk cloth becomes negatively charged, and that is why after rubbing they both tend to attract each other. It is one fundamental property of electric charge that like charges will repel each other and unlike charges will attract each other. Okay. Now let us come to the idea of quantization of charge. Charge on a body is always represented in terms of some integral multiple of the electronic charge, represented by small e. So if we denote charge on a body by small q, then it is always written as small q equals to plus minus small n into small e, where small n is an integer and small e is the charge on an electron, which is equal to 1.6 into 10 to the power minus 19 Coulomb. And unit of electric charge in SI system is Coulomb. Now let us come to electrostatic force. Now as we know that charges, if they are like in nature, then they will repel each other, and if they are unlike, then they will attract each other. Okay, so this means that there exists a force between any two charges, and that force is known as electrostatic force. There is one law which tells us about the nature of the electrostatic force existing between two charges, point charges, or any two charged bodies. And it states that the electrostatic force of attraction or repulsion between two point charges acting along the line joining them is directly proportional to the product of the charges and inversely proportional to the square of the distance between them. So if we consider 2 point charges Q1 and Q2 separated by a distance small r, then according to Coulomb's law, the electrostatic force existing between them is proportional to small q1 into small q2 divided by r square. And therefore the electrostatic force capital F may be written as some constant k into q1 q2 by r square. If the medium in which the 2 point charges are placed is air or vacuum, then the constant of proportionality is given by 1 by 4 pi epsilon naught. where epsilon naught is a constant called permittivity of free space, and its value is given by 8.854 into 10 to the power minus 12 Coulomb square per Newton meter square. Therefore, the electrostatic force between the 2 point charges in vacuum is given by 1 by 4 pi epsilon naught Q1 Q2 by R square. Now, in vector form, the force acting on charge Q1 due to charge Q2 is different from the force acting on charge Q2 due to charge Q1. And they are given by the expressions F12 equals to 1 by 4 pi epsilon naught Q1 Q2 by R square into the unit vector R12. And F21 is equal to 1 by 4 pi epsilon naught Q1 Q2 by R square into unit vector R21. Here the unit vectors represent the directions of the forces. If the medium in which the 2 point charges are placed is not vacuum, it's some other medium, then the expression for the electrostatic force between them is given by 1 by 4 pi epsilon into Q1 Q2 by R square. Here epsilon will be called the permittivity of the medium. So if we take the ratio between the electrostatic force in vacuum and electrostatic force in medium, then we get the ratio as epsilon by epsilon naught, and that ratio is called dielectric constant of the medium. So after doing the theory part, let us now move to the numericals. Here I have included one numerical based on Coulomb's law. The question is, calculate Coulomb force between two alpha particles separated by a distance of 3.2 into 10 to the power minus 12 centimeter in air. So obviously you have to use the formula for electrostatic force given by Coulomb's law, and it is equation 1, where Q1, Q2 are the charges of the two particles and small r is the distance between them. So here, since the particles are alpha particles and one alpha particle contains 2 electrons, so charge on one alpha particle will be equal to 2 times charge on one electron. That is, Q1 and Q2 both are equal to 2 times charge of electron. The distance between them is in centimeters, so you have to convert it into meters, so that the value of small r is equal to 3.2 into 10 to the power minus 14 meter. And after putting all these values for electronic charge, the constant 1 by 4 pi epsilon naught, and the distance between the two alpha particles, you get the value of Coulomb force from equation 1 as 0.9 Newton after the calculation. Okay, so this is how we do numericals based on Coulomb's law. Similarly, you can solve on other numericals which will be based on any particular formula. So that's all for today's class. In the next class, we will learn about electric field and electric potential.